So thank you for inviting me today. I'm really excited to be here, and I just want to say congratulations and thank you to all the speakers that have gone before me. You've made it very hard for me to present now, but they were fantastic talks and a lot of inspiration as well. So I'm going to end this session by talking about Rigour at the grassroots. And this is a consortium approach to student research projects. Now I'm going to try and keep this quite simple because I think it is a simple idea, and stick to time so we can have a good Q&A afterwards. So my name's Dr. Charlotte Pennington. I'm a lecturer at Aston University, and I basically shout about open and reproducible research from the rooftops and try to incorporate this into my teaching wherever possible. So given the audience here, I'm not going to go over this too much, but we all know that there is a problem within research. You'll be living under a rock if you've not heard about the term replication crisis in psychology. And we know overall that a lot of our research might not be replicable, reproducible, and there's a lack of transparency in what's being reported. And there's a lot of explanations for this, given the perverse incentive structures that we're all under, which typically focus on quantity over quality. And again, just the pressures that we're under. But these problems are exacerbated by, because of this pressure, questionable research practices, thinking about selling sexy science rather than truthful things that have gone wrong, and ugly research. And we've kind of now acknowledged that we've got this big issue. And what's really, really nice, and is the point of today's conference as well, is we're looking at ways that we can fix this and solve this. So taking the replication crisis into a credibility revolution. So I've touched upon this a little bit, but one of the issues that we've seen within the literature is publication bias, so only positive findings being shared and published. And also researchers admitting to or reporting the use of certain questionable research practices. So a lot of you will have seen this figure from Chris Chambers' talks a lot before, but with the blue circle, you can see what is typically happening when you read a research paper. So everyone is specifying their hypotheses, they've got a nicely well-designed study, they've collected their data, it tends to be perfect. They analyse the data and they publish this beautiful, seamless, sometimes multi-study papers that really convince the reader that everything went correctly and went right. On the outside of this, you can see things that go wrong within the research process. So we've got a lack of replication within our literature. So Mackle in 2012 showed that this was only 1 in 1,000 papers. I think we're doing a little bit better now, but we're still quite low on replication attempts. We have low statistical power. So again, by putting forward this quantity focus, people are doing a lot of quick studies which have low statistical power to detect true effects. We have spin, and then we have all these questionable research practices such as p-hacking, harking, and we know that their prevalence is typically high within the literature and a lot higher than we would ever want if we want true research questions and true results. So now let's think about student projects. So there is less pedagogical research done on problems in research for student projects, but there are some out there. So in 2018, Krishna and Peter outlined QRPs within student dissertation projects. And they found that 28% of students engaged in selective reporting, around 16% excluded data without any valid reasoning or after looking at the results, and 15% admitting to harking, so hypothesizing after the results are known. And it's important to note that compared to the study on researchers by Johns et al. In 2012, these statistics are a lot lower, but they were predicted by questionable research practice endorsement and the perceived supervisor's attitudes. And this makes complete sense because we teach the next generation of researchers. And if we have an endorsement of certain shaky practices, these are going to be given birth to again in this next generation. We also saw in O'Boyle et al. In 2017, this is a paper from marketing, but I think it does generalise, that ugly initial results from student dissertations can actually metamorphosize into beautiful publications. So what this paper showed is that within the publications of dissertations, there are more significant results reported and a lower number of non-significant results reported. And these aren't the only problems. So the biggest problem really is that student projects are limited by time, money, and participant access. So we have multiple projects and poor resources. When we're thinking about time, students have to do a project in a very kind of rushed manner. They have deadlines. Some of them have less than half a year to design a study, take it through to the execution and the analysis, and then report it. When we look at participant access, we're typically looking at undergraduate samples. So within my own institution, students are given the goal of collecting 30 hours worth of participation, and that disregards statistical power completely. And our assessment criteria focuses on novelty and creativity. And if we've actually got a large number of students with individual projects, this exacerbates all the problems we see previously in our literature. So we've got small, underpowered studies, a lack of replication, potential poor design and analysis, and undisclosed analytical flexibility. So what are the solutions? Here are 3 papers that were kind of written with researchers in mind, but have a lot of elements that can be applicable to undergraduate and postgraduate research projects. So some of the solutions to the reproducibility or replication crisis is to work collaboratively to increase power and replicate findings. We have improving methodological training, so rigorous training in statistics and research methods for our future researchers. We have collaboration and team science, promoting open research such as study pre-registration, open code and data. We have better mentoring and supervision and better teaching. And I think that a consortium approach to the student project can solve a lot of these problems the solutions that are highlighted here. So the underpinnings of my talk are about instilling scientific rigour at the grassroots, and this is training students in open and reproducible science. And this was proposed by Kate Button et al. And I've worked with Kate and colleagues over the past 3 years on large-scale undergraduate consortiums. And this is looking at working in a collaborative approach between and within institutions to focus on big team science, open and replicable research. So it really is that simple. You work collaboratively within or across your institutions to pool diverse skills and expertise, with resource sharing such as equipment and funding. We can widen our participant pool, so now even if each student has to collect 30 hours worth of participation, with around 10 students, all of a sudden you've got larger sample sizes up to 300 and 400. There's less time pressure because people are sharing the kind of design and the organisation of this research. And you have better supervision and mentoring, because let's face it, supervisors have a large number of students that they supervise. I've heard tales of up to 15 in a year. And with such high numbers, there's a lack of high quality research supervision as well. So just by working collaboratively within a team, we have increased statistical power, better generalizability of those samples and the findings, and transparent and reliable findings by implementing open science throughout this training. And what's really important and interesting about this approach is that by embedding open science into education in this way, we have 21st century graduates. So employers are looking for data skills, data management, organisation, teamwork, and really good high quality research skills. And we are training our students to be employable graduates by undertaking this approach. So how does it work? On the left-hand side here, you can see that you've got different supervisors at different universities, but this can also be within the same university as well. And what we have is a lead supervisor or a PhD student or postdoc who will be the overall leader and manager of the project. And then we have supervisors at different universities who contribute to the research design and the process with their respective students. So this is the typical timeline that we adhere to. Supervisors develop an initial research idea over the summer, and the project is then advertised for students to select for their empirical dissertation, so they still get the choice. Students then prepare their own secondary research questions. So we have this primary research question that could be a replication or an extension, or it could be a novel idea. But this is designed by supervisors with expertise in that area. For students to then contribute their original contribution to knowledge, students then prepare their own secondary research questions, hypotheses and measures. Students then individually write their ethical application and obtain approval. Together, the team develops the research design further and the methodology, and then we pre-register this protocol on the Open Science Framework. Students then each help out with data collection, again showing their individual contribution with a target sample size each, and this data is then pooled for high-powered analyses. Each student writes up their research project independently, focusing on their contribution. And then at the very end of this process, the lead supervisor prepares the manuscript for publication, makes all the materials, code and data available, and all of the students are co-authors. And you're a really special audience today because on the right-hand side, you can see my book, which is hopefully coming out early 2023. And you're very privileged because you are literally the first people to see the front cover of this book. And within this book, I talk about this approach and how we can train students in open and reproducible science. So one of the biggest questions I get when I deliver these talks and talk about this approach is this allowed? So within the UK, at least, our undergraduate and postgraduate courses and programmes are accredited by the British Psychological Society. And Kate Button worked closely with the BPS to allow them to recognise the benefits of this approach. And the answer is yes, this is allowed through our accreditation standards. So here you can see the BPS's guidelines around empirical dissertations. And this suggests that students may undertake their projects as parts of a group or a lab group, provided they are still required to demonstrate the above skills, such as coming up with a research idea and question, collecting data and undertaking their individual analyses individually. So we are ticking all those boxes with all the benefits for science and the students around it. So what about individual contributions? Let's come back to this question. So we have a primary research question, and over the years, we've decided to stick with similar research questions because then we can develop our own team's expertise with this as well. So we're not reinventing the wheel every year with a brand new project out of a completely new discipline. So we tend to focus on inhibitory control training. And over the past 3 years, we've looked at how this can reduce unhealthy eating behaviours. So our primary research question put forward by the researchers themselves and the supervisors might be, does inhibitory control training reduce unhealthy eating? And then the students propose valid secondary questions that are vetted within a meeting where we think about, is this underpinned by research? Does it make sense to ask these questions? And we guide the students in asking these. But some of these secondary questions might be, for example, does this differ by gender? Is this moderated by emotional eating? And this student would have then contributed a questionnaire that they can include in the protocol. Does this affect different outcome measures such as liking and craving? And I can't see the right-hand side of my screen, but let's just say, does this differ based on BMI? I think that might be what it says anyway, so you can tell I prepared a little bit. So here are some of our examples over the past few years. So some of these are still in preparation, as you can see, and some of them are fully fleshed, published, peer-reviewed articles. So we've got a lead researcher, a PhD student or a postdoc, and then all of our students are co-authors on these. Now, what's really important is that we embed open science throughout these projects, so that not only does working collaboratively improve the quality of research training, because we're training our students in open science, but it also improves the quality of the research outputs. So all of our studies are pre-registered. We work with the students so they can plan and they can see how this works. We have open data and code. And the way that we work collaboratively, which is really, really beneficial, is by using Google Docs, Google Sheets, and Google Slides. And this means that everybody can access them at any given point for free. But also we can work on these protocols or the analyses or the design in real time together. So it's not about passing the document through emails anymore, but it really is truly collaborative. Now we might be thinking then, could you then implement registered reports within this? So over the years, we've always used pre-registration, so the vanilla pre-registration protocols, because of barriers to time. However, there is a new platform of registered reports known as Peer Community In. And I've not got enough time to go over this in full now, but Peer Community In recommend and peer review pre-printed registered reports. And the amazing thing about this initiative is that they can offer accelerated, scheduled peer review. So now we have the option of embedding registered reports within undergraduate and postgraduate empirical projects by taking advantage and benefiting from this accelerated peer review. So we've not yet tried this, but in the future, we're going to change from pre-registration to registered reports where possible, so that students are also trained in the best science, in the most kind of robust and high quality science. And if you click the link on this slide after my talk, you can see a talk I gave about peer community and registered reports, but this might be the solution for the time barrier of registered reports within student projects. So there are some challenges, and I talk about this in a recent paper with Kate Button et al. And a lot of people focus on these and think, how can we overcome them? So one of them is working with different institutions. You have different deadlines and timelines. So we overcome this by working to the earliest deadline. So for example, at Aston, we have the earliest submission date of April. So the whole team will think about this and make sure that our project is organised with this earliest timeline in mind. People also worry about social loafing. So if you have students who do a lot of the work and then others that are just pulled through this process because everyone else is doing that work. And the great thing about using Google Docs, for example, is you can look at the individual contributions and you can see these in real time. But again, within my paper, I talk about potential reasons for social loafing, and there's usually many different extenuating circumstances why students might be social loafing. And our job as supervisors is to try and recognise that and work with the students to find out why that's happening and to support them. So again, you can have oversight as a supervisor on this to see where things are going really well and where things need a little bit of intervention. And I must say that over the past 3 years of myself working in this team, I've never come across that issue. If anything, students help each other. And when students have got questions or worries, the peer feedback that they get really, really helps them, and it instills confidence in them as well. And they also benefit from multiple supervisors and experts. So actually, social loafing has never been an issue for us. So what do the students think? I got this absolutely lovely email from one of my current dissertation students, and it really warmed my heart. And I asked her whether I could use this within a talk, and she agreed. So she said to me that as part of an interview she had to do an independent review of an obesity-focused lifestyle improvement app. And she found that her dissertation helped so much. And when she was talking about open science in her interview, the panel were absolutely blown away. So I think this really does justice to the benefits that this can provide for students. Okay, so the simple take-home message is working collaboratively and embedding open science into education provides our students with the skills required in the 21st century, while simultaneously fixing a lot of problems we see within the research process. So I've got 3 resources if you're interested in this. Have a read of these articles and it'll take you through step by step how we do this. I've also got a shameless plug to my book and the beautiful cover, I hope you agree, which will be out very soon. And I also just want to acknowledge all my collaborators within the Open Science Consortiums on the left, but also on the right, you can see all of the students we've worked with so far to create high quality, open and reproducible science, the best trained graduate students. Thank you for listening, and I'll open the floor for some questions.